Hi, today I will be teaching you about rational transformations. You will learn how to identify asymptotes and the domain and range of each function, and how to graph a function. The parent function for rational functions is always y equals 1 over x. In order to graph this, we will start by creating a table. So the first, on the x side, we will put our usual numbers, so -2, 0, 1, and 2. Then on the right side, on the y side, we will plug in the x value into this function. So 1 divided by -2 is -1/2. 1 divided by -1 is -1. 1 divided by 0 is undefined, that's impossible. 1 divided by 1 is 1, and 1 divided by 2 is 1/2. Now that we know these points, we can put them on our graph. So -2, -1/2, -1, -1. There's not a 0, 1, 1, and 2, 1/2. If we were to put more points on our in our table, then eventually the graph would start to look like this. As you can see, there are two lines where the function never touches, which are asymptotes. So we have a vertical asymptote and a horizontal asymptote, and normally you will be asked to find these. So in the parent function, our vertical asymptote should be x equals 0, because neither line will ever touch x equals 0. So then our horizontal asymptote should be y equals 0, because the same thing, neither line will ever touch y equals 0. It will get closer and closer, but will never touch. Then we find the domain and range. So since there are two lines on our graph, it would be hard to determine the domain and range. So we normally just say what we cannot have. So x cannot be 0, because that's our asymptote. That's the line that it can never cross. So x cannot be 0, and y cannot be 0, because you can't ever touch that line. So that's how you graph the parent function and the vertical and horizontal asymptote and find the domain and range. For other functions, you do the same steps, you just add in the transformations. This is the transformation form. We see all the same letters and variables that show up in other types of functions, such as h, k, and a. So they do what they normally do in other functions. So knowing that, we know that h moves the graph to the left or to the right, and that it's the liar. So if you go left, then you will have a plus sign, and if you go right, you'll have a minus sign. Then we know that k shifts the graph up and down, and it's normal, so up is plus and down is minus. A should give the graph a vertical stretch, or reflection across the x-axis. For this function, we have y equals 3 over x plus 2. Knowing our transformation form, we know that this function will give us a vertical stretch of 3, and it will translate the graph 2 units to the left. So first, I like to add the asymptotes. So knowing that it will translate 2 units to the left, we go over 2 and add our vertical asymptote. And then we can go ahead and say that that is x equals -2. And then we can just create our table. So we have our x and y values. So we just do it normally. So -2, -1, 0, 1, 2. And then if we were to have 1 in this position, then we would have -1 over 2, -1, undefined, 1, positive 1, and 1/2. Then we can multiply the y values by 3 because that's how much this graph is being stretched. So we'll get -3 halves, -3, +3, and +3 halves. So then we can go over to our graph and graph these points as if this asymptote were just the normal. So we have over -2 and down 3 halves. Then we can do that, and we see our graph has formed. So since we did not have to draw another asymptote because there was no k, no number in the k position, then it will just be y equals 0. Then for our domain, the domain and range is always the number that from the asymptote, but it cannot be that number. So the domain, x cannot be 0, x cannot be 0, and the range, y cannot be -2. For this last problem, I threw in all of the variables. So each variable has a number in its place. So we always start with drawing our asymptotes. So we have a +3 in the h position. So our asymptote will be translated 3 units to the left. Then we have a -1 in our k position, which means our horizontal asymptote will be translated 1 unit down. Now we can start with our table. So if we had the parent function, it would just be -1/2, -1, undefined, 1, and 1/2. But since we don't, and we have a -2, we multiply everything in the y side by -2. So we get 1, 2, -2, -1. And now we plot our points based on our asymptotes. So as if this was the origin, then we would go over 2 and up 1. Then we connect our points, and we have our graph. From here, we can look at our asymptotes and say, and our vertical asymptote is x equals -3. Sorry, our horizontal asymptote is y equals -1. Our domain is x cannot equal -1, and our range is y cannot be -3. When studying rational transformations and graphs, I find it pretty easy to study because you can get a lot of practice with it if you just do it over and over. And also, it's easy to make up your own problems by just changing numbers around and putting them in different places. That's it for rational transformations. Thanks for watching. I hope you learned something from this video.